starting the recording, everybody. Good evening. As always, what's going to happen is I'm going to make some comments here along the way, and these are some of my talking points. And after I talk about these, I'll give Linda the floor, and she can say whatever she needs to say or wants to say. And then there'll be an opportunity for students to have Q&A at that time. Of course, as always, your Q&A is always welcome. And then we have plenty of things to talk about. The stuff I put under content tonight pretty much finishes the statistics part of the course. So there's a good chance we won't finish all that tonight, but we'll see how far we get. And we have plenty of time. And just beginning my comments, then this is week 6 that concludes tonight. And that means we have week 7 and week 8, to go in the first half of this course. And I have to say, we're on course. We're covering the things, and we're on schedule, so we're in pretty good shape. Now, I do have an update on the coverage relative to the book. Again, we've done chapters 1 through 4, 5. Tonight, we're doing some more of 6, okay? 7 is pretty much completed, and I also published material from chapter 9. And when I say published, I mean there are videos out there for you to watch. Now, I realize some of you might not have watched those videos yet because it wasn't all that long ago I put them out there, but you do want to be watching them, and we're going to be working problems as we often do, assuming that maybe you've seen them, but we're going to remind you of some of the headlines from there so we can do some problems and things like that. And Linda, I'm going to look to you in 7, at least as you're able to help me with things, and you keep me advised because I know you're juggling several things, so let me know if I'm asking you to do just let me know, but I'm probably going to, be looking to you to do things as we go along. And so just keep me clued in as to, what's going on and what you might need. And I can solo this, but it's so much better when you're here. And that certainly is true. Okay. Oh, and then I'm making progress on the testing. I had 2 meetings this week on the testing, and I'm almost ready to give you details, but I don't want to spring this on Linda in the session tonight. So Linda, if you are on campus tomorrow, I would like to talk with you. And it won't have to be a long talk, but we're going to talk about a couple of things, and this class is one of them, okay? And it's nothing to be apprehensive about. It's just, okay, I see how things have to be, and they're going to have to be a little bit different, and we'll be fine. But it's going to, I want to talk with you first before I tell everybody, just so I can benefit from your input, and also so you're not shocked with what I'm saying as well. Okay, and
Sounds then I'll track you down tomorrow.
Okay, and I'll be around. I mean, I do teach a bunch tomorrow, but I think you can track me down. Okay, accommodations are firming up. That's good. And again, I'm working on those. I'm going to share that as well. And the accommodations are not going to be as flexible as they once were because COD is becoming less flexible, but we'll work through it and we'll get there. I'm still going to be publishing some LSA solutions, and grading up through midterm will be there, so you'll know what you have. Generally, people are going to have a nice cushion going forward, turning those things in. I think that's really all I wanted to say. Linda, do you have something you want to share?
Not especially. The GSG traffic is slowing down a little bit, so if you guys are looking for help or are struggling, then you can absolutely reach me there. I'm not sure if everyone is aware, but there is a GroupMe that I'm also a part of, so if you guys are looking to get help on just little tiny things, just quick questions in between GSG sessions, then that may also be a good option if you're looking for help.
Okay. All right, so we'll take that as being the thing. Taking advantage of these GSGs is important, and I've really got to say, probably as you're approaching the midterm, that's going to be, maybe even doubly important, because we're approaching what's known as a high stakes assessment, not low stakes assessment. So, okay, so that'll be good. I'm going to count to 10 Mississippi and see if there's students Q&A, and I always will restart my count if someone asks a question. So we're open for questions, I suppose. Okay. Oops. All right. And I'm sorry, I didn't mean to say oops when you did it, but I was about ready to say, well, let's start. So you have a question, your hand is up. So go ahead and can you speak your question? Go ahead.
Hello, Professor. I have a question. Like, I don't know, like, you received my email or not, but since I'm not be able to go to the campus to get the midterm test, and I already sent you a email.
There is, yes, I know I'm interrupting you, but I can speak to you as well as others. You are, unfortunately, and I say this unfortunately because I'd rather do the other thing. I'd rather, there were no COVID. I'd rather many things, but I am not going to, and you're making me share part of the things, but we're not going to do this in the testing center per se. So you will not have a problem, and you certainly will be accommodated, although the nature of the accommodation, will be yet to be shared. Okay? So don't worry about, you're not going to be able to, I know you can't go to the campus. That's not going to be a problem for you. Okay?
Thank you, Professor.
Okay, excellent. Now I'm starting my count again. Okay, we hit 10 Mississippi. So we're going to start. Now, and Linda, I don't know, maybe I will try to pick the PowerPoint slides and things like that, but I'll certainly try to engage you. First thing we're doing, I guess I should go back one to start. We're going to talk about grace notes, because I'm sharing grace notes with you, and I will share grace notes. You'll know what the final grace notes and the complete grace notes are. But here's some grace notes that we're going to be touching tonight. And so when we're working these problems, and Linda, if I do a handoff to you on one of these things, which I'm likely to do, I want you to know what is here. So there's this stuff from chapter 5, and we are going to talk about the combinations, permutations, and permutations with non-distinct elements again. So Linda, if you have to go to this, you will. And Amber has a question, it looks like, or a comment. Amber, what's up?
So since we will be going in to take the test, would it be possible to send us the grace notes a few days ahead so I can print it out at the school?
You will have the grace notes beforehand, yes. Okay. And I really was not planning on getting into that just because I wanted to talk to Linda about it. But and again, I'm not saying we won't talk about it, but I think we've. Yes, so yes, you will see all the grace notes before, and that will be useful for you, because then you can say, oh, gee, it's not there. I have to remember something if there's something you need to remember. Okay, so that is, let's see, Amber's question is answered then, I guess. And Linda, I'm just saying this is here because you might want to go back to that and tell people what formula you're using if you're doing a problem or something. Okay, and then I go into, and this is taken from chapter 6, and this talks about what a binomial experiment is. And we're going to come back and look at this slide later. We're not going to cover it now, but when we get to the binomial stuff, we will talk about it. So it's here, and that's where it is. And these are the formulas from chapter 6. And the formulas that you see on the left-hand panel on this slide are the formulas talking about general discrete probability formulas, and the ones on the right panel of the screen of the PowerPoint slide are specific formulas for the binomial probability distribution. And again, I plan to talk about that some tonight as well. So that is chapter 6. 7 you've already seen, and I'll show you 7 later. 8 we're not really focusing on in this course, but this is chapter 9. And these are things that are in the videos. And again, if you say, oh, gee, I watched all these videos, then that means you're up to speed on this. But some of you maybe haven't seen the videos yet, and so we'll do these. But Linda, the formulas are here, for you and I to jump back if we want to show people what formulas we're using. So that's, again, a little bit sliding past grace notes. And also the LSA birthday problem has been posted and is underway. Okay, now what I'm going to do here is I'm going to begin with this slide, which was one of the slides that we did last time. And what I want to do with this one is I want to talk about number 54. And some of you might have been surprised last week when I said, Linda, do you want to take this one? And she says, no, why don't you handle it? Well, I know exactly why she said that, and that probably was a good choice of hers. But the problem with this problem is that it's subject to interpretation. So I worked it one way last time, and and one interpretation, which I think was a reasonable interpretation. But tonight, we're going to talk about a different interpretation that is way more complicated. And so I'm going to remind you of what I did then, and then I'm going to talk about what I'm doing tonight, and I want to make sure that you understand the difference. And if I ever write a problem like this, well, first of all, one thing is I tend to share the stuff I write with Linda, and so she can say, oh, that's a bad problem, or this is unclear. I also share things a lot of times with Cheryl Martin, and Cheryl Martin, who runs the Learning Commons, also has very good comments often. But I'm going to rework problem 54, and we're going to talk about 2 ways 54 could be interpreted, I think. And I may, at the end of all that, ask Linda to chime in, but we'll see. And then Linda, I don't remember, but I don't think we finished, or if we did it in a real big old hurry. So we're going to do 55, and I'm going to take care of 54, but I may ask you to do 55, okay? And so we could, we'll see how all that goes. Okay, so this is the one. The family has 8 children. They have exactly 3 boys, and it says how many different birth and gender orders are possible. Okay, so I'm going to share a whiteboard with you. And let's see, I have to find a whiteboard. Here we go. And there's the whiteboard. Okay, and Linda, I might be writing some things down here that require some calculations to do. And I might just write, things, formulas and stuff. And so if you could make note of the calculations that I'm doing here, and maybe then we'll switch and we'll let you do some Excel calculations with these, because definitely these would involve Excel. Now, what I did last time on this problem, and I think I have to pick a color before it lets me do anything. So we had 8 children, and the children are happening in order from left to right. So that's 1, 2, 3, 4, 5, 6, 7, 8. And I think the days of people having families with 8 children is probably more in the past than it used to be, because it costs a lot of money to raise children. And so anyway, but this family had 8 children, and they had exactly 3 boys. Now, my interpretation last time was this. last time I interpreted the problem, and I don't think this is wrong or right. It's just how I interpreted it. Last time I interpreted the problem to ask how many different ways could we have 5 girls, and I'm going to say 5, come on, Jim, 5 G's and 6 B's. No, not 6 B's, 3 B's. Got to start turning lights on in here. B's in these slots. And the slots are in order because, I start over there on the left-hand side. And there are 2 ways that I could do this, okay? One way is I could say, well, let me just pick where the B's are going to be. So I have to pick where in these slots going 1 through 8 can I put the B's. And that means that in this case, I'm saying that this could be, so the answer could be, and I'm going to say 8, choose 3, or it could be, if we're talking about where to put the girls, which would have been a separate thing. But you see, if I figure out where the boys are, everything else has to be girls. And I figure out where the girls are, everything else has to be boys. And this would be 8, choose 5, because there are 5 girls. Come on, Jim.
I'm not seeing anything on your screen.
I
just see the lines that you drew, but I don't see the numbers.
Oh, well, no. All right. You're going to. The way this program works, I think I have to be outside of it. Okay. And so I'm clicking outside of it now, and now you can see me writing. Yes?
Yeah.
Yeah, it's good now.
Okay, and that's just the way it works. If I make a text box and I'm typing in the text box, and I was narrating this as I was typing it, but the answer could be 8, choose 3, or 8, choose 5. Now, Linda, if you take this on in a bit, I'm going to ask you as one of your first acts of business is to remind the students of how to do 8, choose 3, and 8, choose 5, and in fact, demonstrate for them that you get the same number either way. And I think that number is 56, but I'm working on my memory and it could be wrong. Okay, so anyway,
Yes, it is.
Okay, so that was the interpretation last time. Now I'm going to go, and it will look like I'm dark, but this time, come on, there we go. So I'm making a new, how come it won't let me make a new text box? What's wrong? There. I think I have to tell what color I'm typing it now to. Maybe not. Oh, there it is. Okay. Hold on. I'm going to put it somewhere else. This is a little bit clumsy. I will be so happy when I'm back in the classroom all the time. Okay. But, and again, you can't see what I'm typing, but I am typing. There is a different interpretation possible, and I think it's a legit interpretation. Suppose the boys are named Mo, Larry, and Shep. So that's S-H-E-P. Okay, so that is what the boys are named. And the girls are named, let's see. I'm thinking of crushes I had on people. All right, so we had Emily, Ruth. I want to make these have different names. Bonnie, Emily, Ruth, Bonnie. There actually haven't been many names here. Let's see. Suzette and my wife was the last person I ever, okay, so, and her name was Pat or Patricia. Okay, now there's a different interpretation because I'm saying how many different ways could these 8 people been born as we go through. And now I'm moving this so you should be able to see the words I typed. But there's a different interpretation possible. Suppose the boys are named Mo, Shep, and Larry, and the girls are named Emily, Ruth, Bonnie, Suzette, and Patricia. Okay, and so you could say, oh, so these are my girls and these are my boys, but how many different ways could they be ordered? Now, I hope everybody understands that this is a way different interpretation. And there's many more ways that this happens, because even if I had all 5 girls first, Emily, Ruth, Bonnie, Suzette, and Patricia would be different than Patricia, Suzette, Bonnie, Ruth, and Emily. Okay, so this is pretty complicated. But what I'm going to do is I'm going to do this in steps, okay? And this allows us to talk about another principle where we had, and you might remember in the video that I talked about, you go to a restaurant, you can pick 1 appetizer, 1 entree, and 1 dessert, but you're picking those things, but you have different numbers to pick from, and so you have tasks. You have to pick the appetizer, and then you have to pick the entree, then you have to pick the dessert, and those are distinct, independent tasks, and so you multiply everything together. So here is the order in which I'm going to do this. First thing I'm going to pick, and I need to do another thing here, so I'm typing, but you're not going to be able to see it. So first I'm going to pick Where the Boys Are. Actually, that was a movie, Where the Boys Are. Okay, it's an old movie, but anyway, my first task is pick where the boys are. And by the way, if I've picked where the boys are, the number of ways that can happen, then I'm picking where the girls are as well. Okay, but then my second task is, so I know where the boys are, then I pick, next I pick the order of the boys. I just typed the order of the boys. The order of the boys. And then last, I pick the order of the girls. Okay, so I'm going to fix this so you can see what I typed, and now you can see. So those are the 3 tests. Now this is a way different interpretation of the problem, and I'm going to, okay, so I'm just going to type what happens. I'm going to do it in between. Well, let's see, where should I put it? This is a little bit of a problem. Okay, I'm putting it in between these 2 last paragraphs. That didn't work. I'm putting it above these 2 last paragraphs. Okay, so I need to get this. All right. So task 1 is, that is 8, choose 3. So I will type 8, choose 3 times, because I have to multiply these, and then I have to pick the order of the boys. Well, I could pick the first boy that appears 3 different ways, because I could do Mo, Larry, or Shep first. So that is going to be times, and that's going to be 3 times 2 times 1, which is called 3 factorial. Then, so that gets the boys there and where the boys are, but now I get to pick the order of the girls. And I could pick 5 different girls to be first, and 4 to be second, and so on and so forth. So that is going to be times, and this is going to be 5 factorial. This is going to be a way bigger number, and now I've changed it so you can see that. And you see that's interpretation of the problem. And Linda, after class last time, and I'm sharing this with everybody, but I'm sharing it with Linda. After class last time, I thought, oh, gee, I just gave one interpretation of this. And I think when we taught this course once before, I also picked this problem, and we got a little bit bogged down in which interpretation was right and things like that. So
Yeah, that's why I skipped it.
yeah, I know, and I was and by the way, I wasn't thinking about that till after class, and I said, oh, that's why she did that. Okay, but then I decided, well, let's turn this into a learning opportunity, and that's what we're doing right now. Now, I've done my contribution to the learning opportunity. Are you prepared to do these numbers with the students with Excel? And if you want to weigh in as to which interpretation, I think it is ambiguous myself. I don't think it's clear which interpretation it is.
Yeah, so
Linda,
I've already thrown the numbers into Excel. If you'd like, I can share my screen though.
Okay, why don't you do that, please?
Okay. So I do have the 8 choose 3 over here, and if we did do the equal CONBIN for 8 choose 5, then we'll get the same number.
Hey,
the
you're
3
still
factorial.
showing, Linda, you're still showing up like that screen going off.
There we go.
Oh, now it's better. Okay.
Okay. Let's see. Let me make this a little bit bigger. So I do have my 8 choose 3 and my 8 choose 5. They do give me the same number, which is 56. Then I figured out what the factorial for 3 and for 5 are by doing the equals fact function. And then from there, I just multiplied these 3 numbers, and I got 40,320.
Okay, now that's for those. Oh, that's all 3 numbers, yes? Okay.
Yes.
Okay, so you see one answer is a tiny answer and the other one is a big old number. But that's what we have. I guess I'm going to pause and say, is there any question? And again, one of the reasons I was asking Linda to do that was because you guys do have access to Excel, and you really want to use Excel to do those calculations, not do them, by hand or use the on-screen calculator. You're much better off doing it this way. Okay, I counted to 5 Mississippi, so I think that's good. And now I've got to think about, I'm not really sure, how do I get back to my PowerPoint slides, Linda?
I can do it.
Okay, why don't you do it? And Linda, if you're comfortable doing this, and by the way, I am glad that Seven's enjoying, class time tonight. That is good. But now we're going to go back and we're going to do that problem that is the DNA sequence. Now this one, I'm going to set this up, but Linda's going to do the calculation in Excel. And I don't think we actually did the calculation last time. I think I just kind of,
yeah, we just set it up.
Okay, but we'll do the calculation tonight. But just to remind you then, you've got 3 and 4 is 7 and 3 is 10. I think I counted that as 11 last time. That was horrible. 6 and that is
no, you
10.
Counted 10.
Okay, so anyway, there are 10 different elements here, but 3 of them are A's, 2 are C's, 2 are G's, and these are different acids. 3 are T's, and so you see you can't tell the difference between any of the A's. So that's a different kind of thing. And Linda, at the end of this, I want you to speak to this problem, but then Linda, we're going to do 2 other problems. I'm just going to make them up, but I'm going to throw them at you, and you will be fine doing these. But we're going to do variations on this DNA sequence thing. But Linda, can you run with this one then? And so go back to the Excel thing and talk to it, please.
Okay. So first of all, we are doing a permutation with non-distinct items. So I'm going to copy that and put it into my Excel file, just so we have the formula handy. Now we did say that there are 10 total items, so that's going to be my n in the numerator. And then for the distinct part, then that's going to be the n sub 1, n sub 2, and so on. So if I'm doing this, then I need to get 10 factorial first. And then we actually learned from before that 3 factorial is 6. So what I'm going to do is 2 times 2 times 6 times 6, and that'll be my denominator. So I get 144, and then I'm just going to divide these numbers to get my answer. So there are 25,200 ways.
Okay, I'm counting to 5 Mississippi in case there's questions of Linda on this. Yes, we have a question, Linda. Go ahead, please. Yeah, go ahead, Linda.
Hello, Linda. Could you please re-explain again, like where you got it 144?
So the 144 we got just by computing what the denominator is. So in this case, we would be doing equals factorial for 2, which in that case is just 2. So because they said there are like 2 A's, 2 G's, something like that, there were 2 of the objects had 2 different repetitions, and then the other 2 had 3 different repetitions. So that's why I'm doing the 2 factorial and the 3 factorial in that denominator. So that's why I did 2 times 2 times 6 times 6.
Basically, Linda was doing that in her head, and she's you know, good enough to do things like that in your head. You might want to, you know, type them out. Okay. Now, all right, so now, and I count, I guess I will count again, and I'll count aloud this time. This is 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, and 5 Mississippi. But saying Mississippi all the time reminds me of a riddle, Linda. And the riddle is, what has 4 eyes and cannot see?
I'm going to say Mississippi.
Yeah. So now the question is, and I don't know if Linda wants to write the question or you guys just want to, you know, think about the question, but the question is, how many different ways can the letters in Mississippi be arranged? So Linda, you have the ball, or do you want me to take over, or are you doing okay?
No, I'm okay.
All right.
I just got my hand in a dog's mouth, so it might take me a while.
Okay.
All right, so first of all, I just wrote out the word Mississippi. That way we can actually see what's going on here. Next, how many letters are there total? So we have 4, that would be 8, 9, 10, 11. So my numerator in this case is going to be equals factorial for 11. Is everyone okay with that? Okay, I'll take that as a yes.
Yeah.
All right. So then next I'm going to break this up by letter. So I have an M, an I, an S, and a P. And those are all the different letters, right? So now I'm going to go through and count how many of each appear. So I have 1 M. I do have 4 I's, as Professor Bradley said. And then I have 4 S's. And let's see, 2 P's. So now what I'm going to do is get the factorial of each of these. And that's going to help me get my denominator. So I'm going to drag that down. So those are the factorial for each of the counts for all of these numbers. And then from there, to get my denominator, then I'm going to do equals and then multiply each of these. So now that I have my numerator and my denominator, then all I have to do is just divide. So 34,650 ways.
Okay, and one of the things that happens when Linda is doing this, sometimes she is very organized and very clever in the way she arranges things and stuff like that. And that's because she's done a lot of this kind of stuff and she is clever to start with. So anyway, you know, that's how it happens. Now, that's not the only word. In fact, there are other states that have things like that. And the 50th state that became the United States also has some multiple letters, and that's Alaska. Okay, and Linda may spell that somewhere. We're not going to do this problem, but Alaska is let's see, Alaski. So there are multiple. Well, maybe yeah, there are. There's more than one A anyway. Yeah, Alaska. There's two A. I guess there's three A's, right? Okay,
Yep.
so anyway, you know, so that would be, you know, a different kind of problem, and there's probably other states that are like that as well. Okay, so anyway, there you go, and I think I'm finished with that. And so let's go back to the PowerPoint slide, show Linda.
Okay.
And wow, we have a whole bunch of problems here. Okay, so I'm going to go to the next slide because we killed that off. All right, we're going to do number 61. And by the way, there's other problems here. We're not going to do all these problems, but a student might want to do this. We're going to do 61, and then I'm going to do 61, Linda, and then, or actually, I'm going to do enough of 61. Is this such that I can write on this?
You should be able to. I was having a little bit of trouble writing on the PowerPoint slides on Monday, so you may need to switch to a whiteboard.
Okay, let's see what happens. All right, let me read this first, and I need to, let's see, I need to forget that for a while. Okay, so the grade appeal process at a university, and by the way, there are grade appeal processes. So students can say, oh, I don't think I should have gotten this grade, and there is a jury. And the jury is actually composed at the College of DuPage as well as other places this way. And so what they do is they say, well, we should have some faculty on here to, you know, have a faculty perspective, but we also should have a student perspective. So somebody's, you know, arguing about a grade and they filed a formal complaint, and so they present evidence. It's kind of like a trial, and you have this. But here's what you do. And by the way, I do know, I have never served on this committee. I do know faculty members who have, and they say this is really a very painful duty. And so I don't think I'm ever going to volunteer for this. But anyway, you have 8 students and you have 10 faculty. Okay. Now, but you pick 5 individuals and you randomly select 5 people from here. Okay. And so what we're saying is, let's see, what's the probability of selecting a jury of all students? Okay, Jasmine has a comment. Yes, Jasmine. Was your hand up? Maybe that was a inadvertent touch. Sometimes I call people on my cell phone and I don't intend to. So, you know, chime in again, Jasmine, if you got a thing. Okay, if you have a question. Okay, so what's, oh, yes, Jasmine is back. Jasmine, go ahead with your question, please. Yes, Jasmine. Now she's joined the session. Jasmine, do you have a question? Okay, the hand went away, so I think she maybe doesn't have a question. Okay, well, what's the probability of selecting a jury of all students? Okay, well, what that's going to be is, and I'm going to try to do a text thing here. So all students, the numerator is going to be let's see, there are 5. So this is 8. Let's see, I'm going to try to do this differently. There's going to be 8, choose, come on. There's going to be 8, choose 5. That's the number of ways we can pick 5 students out of 8 students. But then times, and that little star means times, and then I'm picking 0 faculty. So this is going to be 10, and then it's going to be choose, and then it's going to be 0. Now that is the numerator, and then we're going to divide by, so that is the numerator, and the denominator is going to be, and I'm just going to space it. I know you can't see anything yet, but the denominator then is going to be how many different ways could I really choose, you know, a jury of 5, and that could be 18 choose 5. So this is 18, and then this is choose. Come on, Jim. Choose. Keep hitting the wrong key. 18. Oh, I see what's happening. That's not good. There it is. So this is going to be 18, choose 5. Okay, and Linda's going to remind us how to do this in Excel. And now you can see what I wrote. So the numerator is this thing up here, the 8, choose 5 times 10, choose 0, divided by 18, choose 5. But before Linda pounds the numbers in there, what we're going to do is I'm going to want to pause and see if there's any questions about what I did. So task 1 was how many different ways could I choose the students? Well, I picked 5 from the group of 8. And then how many ways can I choose the faculty? Well, I can't pick any faculty in this part A. I get 10, choose 0. And this is all over 18, choose 5. What's the probability of selecting a jury of all faculty? Well, that is going to be 10, choose 5 times 8, choose 0, all over 18, choose 5. And what's the probability of selecting a jury of 2 students and 3 faculty? And I'm going to write that one again. I guess I'm writing A and C, and we're going to skip B because B is so similar to the other one. So the probability of selecting 2 students is going to be 8, choose 5. No, 2. 8, choose 2 times, and then it's going to be 10, choose 3. So it is 10, choose 3. That's my numerator. Now my denominator is still 18, choose 5. So it's 18, choose 5. Okay, and now you'll see what I do. So this was A and C that I did here, and I skipped B because B was a lot like that. And Linda, maybe it would be worth, why don't you just pick one of those? I don't care which one. Probably C is better. Can you remind the students of how they would pound that into their calculator for C?
Yeah, absolutely.
Okay, Linda's taking charge then.
All right, so if we go to Excel, then I'm mainly going to focus on the numerator, which I wrote out what we're actually doing here because I already got the denominator earlier by doing a combination with 18, choose 5. So to get my numerator, then I'm going to be doing another combination, but now I'm doing 8, choose 2. And then over here, I'm going to do another combination for the faculty, and this is going to be 10, choosing 3. And then I'm going to multiply these together to get my numerator. So I have my numerator. Now I'm going to divide it by the denominator that I found earlier, which is that 8,568. And I get about 40% chance.
Okay. All right. So anyway, there you go. And that, I think that was a good example. Let's go back to the PowerPoint slide, please. And we're going to, and this, by the way, Sebastian made a comment, and that's a very powerful way. And I actually like problems like that. Okay. And by the way, there's other problems here. We're not going to do these today. Acceptance sampling is interesting, and reliability is interesting too. And some students might want to look at those, but we're not going to look at those today. And this is also really a good problem. This is getting three of a kind in a poker hand, and this would be a good thing to read as well. But we're going to keep moving on, and now we're going to start talking about discrete probability introduction. Okay, now the introduction really was back, and let's see. Linda, can you go back to the it's chapter 6. It's the grace notes, and we're just going to remind people of the formulas there. It's probably the next slide, I guess. No, well, it is, but go to the next one. Okay, it's the left-hand panel on here. So these are discrete probabilities. So what you do is you take every value of x times the probability of x happening, and you add them up. Now, when you have a discrete probability, you have a finite a set of events that can happen, and each of them is disjoint. So, for example, if your apartment has 3 rooms, then it doesn't have 2 rooms, and so on and so forth. And we also have a formula for the standard deviation. Now, the big thing to do with these formulas is being able to use XL for these. And so what we're going to do is we're going to go, and so Linda, let's go back to the slides where we were, and we're going to advance that. That's all I want to say about this. That's where the formulas come from that Linda's going to use. So Linda, go ahead, and we're here. Go to the next slide, please, Linda. Okay, I will read this, and Linda probably will be gainfully employed putting that in Excel or something, but I will read it. Okay, in the and Michael Sullivan, he's the author of the book, and he, asks his students questions. But anyway, he asked, how many televisions do you have? And then he figured that out. So he has a discrete probability distribution. So he has number of televisions in this table, but then he has the probability that you had those things. So the students in his class that he surveyed here, some of them had, actually none of them had 0 TVs. That's a little bit amazing. But then there was at least somebody in the class that had 9 TVs in a class, or in that. So, okay, there's a whole bunch of questions. And Linda, you probably want to copy the questions as well. Okay. Linda, we're going to skip B. But we're really going to talk about, these other questions. And so we're going to verify it's a probability distribution, talk about what is the mean, what is the standard deviation, and so on and so forth. So Linda, did I give you enough time to do your magic here?
Almost. I'm just copying over one more thing of notes from the PowerPoint.
Okay, good enough.
Let's see.
Linda is really quite amazing because she not only does all this stuff and does it quickly, but she has to guess and anticipate what I'm going to do. And that's probably not easy either, that last thing.
Well,
Okay,
after a few years, it gets easier. For some reason, I can't find the notes, though, so I'm just going to jump into it.
Yep, go ahead. That'll be fine.
All right. Sorry, I'm also wrestling with a dog at the moment.
If the dog becomes too much, let me know. I can do it, but
no, it's all right.
All right.
Okay, can everyone see this okay?
It looks good.
All right. So first thing we are doing is just verifying. And I don't see any probabilities that would be listed out in column B over here that are negative. So really, I just need to make sure that all of these add up to be 1. So I'm going to go ahead and take the sum real quick. And they do add to be 1, so it is a discrete probability distribution.
Now we're skipping to C.
Okay, so next thing I'm doing is getting the mean. So first thing I need to do here is actually multiply the probability by the value. So I'm going to call that x times p of x. And I'll use my Excel formula to multiply. And then I can just drag that down. So once I have all those, then I'm going to add them up, and that'll get me my mean.
Okay, so the mean is 3.21.
Okay. So next thing we need to do is get the standard deviation. Now those formulas are usually a little bit more complicated, so I'm going to go ahead and copy and paste this so we have it to reference. Okay. So I already have the mean, so I can go ahead and subtract that from all of my x values. So I'll put that over here where it's just x minus x bar. And I do want to use my absolute cell reference so it won't change when I drag the formula down. So my mean is in D13, so I'm going to do a $D, $13, and drag that down. Next thing I need to do is square that, as we see in the formula. So I'm going to call that x minus x bar squared. And just take the previous column and square it. So I'm doing the little caret and then a 2 for that. I'll drag all those down. And then the next thing we do before we take the sum is multiply by the respective probability. So I'm going to have times p of x. And I'll take that previous column and multiply by probability back from before. 7 agrees. So I got everything inside the brackets. Now I just need to take the sum of all those. And then from there, I'm going to take the square root. So you could do this either by doing the SQRT function, or you could do it by raising that number to the 1/2 power. So the standard deviation in this case is about 1.74.
And again, you really want to use Excel to do a formula like this. Okay, thank you, Linda. That was great. I don't know what the other questions are here. Let's see. Oh, what's the probability that a randomly selected household? I can't tell what D is. Maybe D is. We did D. D is done. Standard deviation. So what's the probability that a randomly selected household has 3 TVs, Linda? What is it, and how do you know?
So that would just be that 0.176, and I got that directly from the problem and the information that they gave me.
Okay. What's the probability that a randomly selected household has 3 or 4 televisions? What would you do there?
So for 3 or 4, then I would need to actually add. So I'm going to take the sum here of the 3 and 4 probabilities. So I get 0.362.
Okay, and then last, it says something about what's the probability that there are no televisions? Let's just
So our
answer that one.
distribution says that it's 0, but this is definitely not an impossible event since it is absolutely possible to not own a television.
Okay, so that's all good. And again, in answering the question, we're saying this is a probability distribution. So there were two questions there, and Linda answered them both correctly, but the answer would be 0 for the first one. Amber has a question. Amber, go ahead and pose your question, please.
For the standard deviation part of this question, would it be possible to use the Excel formula, like the standard deviation formula, or do we have to do all of that?
So the standard deviation formula that we showed you before only works when you're working with the raw data.
Okay, thank you.
So you would have to do this, okay, for this kind of problem. And that was, of course, I'm not supposed to say that was a good question, because then sometimes I don't say it's a good question. That doesn't mean it was not a good question. So anyway, all right. So
that was a question.
That was a question. Yes. It is a useful point. That's for sure. Okay. Let's go back. And I think I'm finished with discrete probability distributions. I think that's all we need to say. So now what we're going to do is, in that same chapter, though, we talk about a very special probability distribution, and this one is called the binomial distribution, okay? And I'm choosing not to talk about this tonight. You guys can look at this, and you know, if you have questions, it would be a good thing to ask about. But we're going to go ahead, and we're going to, and this is a transition, and well, I don't know why that. I'm not sure how to fix that. That looks really bad. So Linda, go back, if you will, to the PowerPoint slide that we had at the beginning that talked about what is a binomial event, or a binomial situation, I guess I want to call it. Okay, so here we go. And I'm starting reading in the second paragraph, and I do this in the video, so you know it's in the video and you can see that. But I'm just telling you now. And Linda, I think you and I are going to interact on this. So a probability experiment is, because I'm reading this to you guys, a probability experiment is binomial if, and so you have to have all these things. The experiment is performed a fixed number of times, and it's called n in the formula. Each repetition is called a trial, but the requirement is it has to be a fixed number of times. The trials are independent. That means that the outcome of one trial does not affect the outcome of the other trials. For each trial, there are two mutually exclusive, disjoint outcomes, and we call these a success or a failure. Now, success and failure is a kind of goofy, but we say it is a success or a failure. There's two outcomes. You could think about tossing a coin. Either you get a head or you get a tail. And that's binomial. That's because it means there's two. And then the probability of success is the same for each trial, because if you're tossing a fair coin, the probability of getting a head is 1/2 each time. Okay, now we're going to check to see if some things are binomial. So Linda, go back to, it's going to be the slide after the one that was not appearing clear. And so let's see, yes, good. Okay, so I'm going to read these. I'm going to, and the directions say, determine if the following probability experiment is a binomial experiment or not. And this is just to get you used to thinking about binomial experiments. So if the probability is not binomial, state why. Okay, so Linda, I will read these and you will respond, and we'll do, we won't maybe do all of them, but we'll do some of them. In a random sample of 15 college seniors is obtained, and the individuals selected are asked to state their ages. Is that a binomial experiment? And if not, why not?
It is not a binomial experiment, but it could be if they bracketed the ages. So if they said it was like less than 30 and more than or equal to 30, then they could make it binomial. But as it's given, then there are more than two ages. Okay,
so it's, and I agree with Linda's interpretation. And I should say more if it was something like that. For example, if you were going to bars, You know, you could say, are you old enough or not old enough? And that turns it into a binomial thing. Okay, let's go to, and we're not talking about fake IDs and stuff like that. All right, number 9. An experimental drug is administered to 100 randomly selected individuals, and the number of individuals responding favorably is recorded. Is that a binomial experiment?
It depends how they're grouping it. I would say it is if they're just saying favorably or not favorably, but it depends on if they have a neutral option. If they do have a neutral, then it would be no.
Yeah, and we're just counting the number of people who respond favorably. So I mean, and Linda's you know, discriminating, and she's making good comments, but that's just, was the treatment considered a success or not? Okay, and so success or not. Okay, success or failure. And if it was neutral, no change or something, that's a failure. It didn't help. Okay, let's do 11. 3 cards are selected from a standard 52 deck without replacement. And by the way, without replacement matters. The number of aces selected is recorded. Linda, is that a binomial experiment? Why or why not?
I would say no because the trials are not independent.
Indeed, because you don't replace the card, so they're not independent. If you drew an ace the first time, that changes the probability. In fact, whatever you draw the first time, it changes the probabilities. Okay, so that is good. We'll go to 13, Linda. A basketball player who makes 80% of her free throws is asked to shoot free throws until she misses. The number of free throw attempts is recorded. Binomial or not binomial?
I would say no because it's not a set number of trials. But I guess
Yeah,
after the fact it would be.
well, yeah, but I mean, I think there's even more reasons, but the answer is no, that's not binomial. I think there's a lot of things that can happen there with that one, but the answer is no. I think we have one more. 100 randomly selected U.S. parents with at least one child under the age of 18 are surveyed and asked if they have ever spanked their child. The number of parents who have spanked their child is recorded.
Yes,
Binomial,
this would be binomial.
Okay, excellent, Linda. Thank you. That's good. And that's just getting you thinking about those conditions because you don't want to apply the binomial formulas if it's not binomial. So, Linda, let's go then to another, the next thing. Okay. Next
I
slide,
actually got to
please.
run since it's after 7, but I will get into the next slide.
All right, I lost track. I'm sorry, Linda.
No, you're
okay,
fine.
that's good. Yeah, now run. Okay, so see Linda run. Okay, so here we go. We're going to do some computations, and you see there is a formula, and Linda showed you what the formula is. It's there, but you never want to use that formula. What you want to do is you want to yeah, I forgot that this was Wednesday. Okay, so anyway, what we got is we have N, that's the number of trials. We got P. P is always the probability of success, and X is the number of successes. So I'm just going to pick one of these and do it. Actually, I'm going to pick more than one of these. I'm going to do 17, and then I'm going to do 24 and 25, I think. 24 and 25. Okay, 17, 24, and 25. Now I'm going to call up Excel, and we're going to use Excel for this. And so I'm going to share my screen, and I'm an application screen, and I'm going to share it. And let's see. So it is there, and I'm sharing this. And soon I'm going to be calling up Excel. So I'm calling up my Excel. And it will be there soon. And I have a lot of special programs here, so it turns out that it takes a while for it to open, but soon you will see it opening. It's taking forever. There it is. Good. So I will do this. Amber, can you see Excel?
Yes.
Good. Okay, so this is Excel, and I'm just going to show you the formula. And Amber, I don't know if you can look at that slide, but I'm going to ask you what some numbers are. But what we're going to do is there's a formula for this, okay? And so I'm going to do the formula, and the formula I'm going to do by clicking on here, the f sub x, and it's over here. I will move it into the screen. And this I want to look at all, and I know it's spelled something like binomial, but that begins with a B, so that's pretty quick. So I'm going to go down here to binomial, and so that is B-I-N-O, and this is binomial distribution, okay? And there's different things that I can do, but I'm going to click on this one that is binom.dist, and I'll click on that, and this is what it says. You're going to put in, these are the arguments for this function, you're going to put the number of successes, the trials, the probability of success, and then I either say I want it to be cumulative or not cumulative. I'm going to put a 0 in for this last thing, and so that's going to be not cumulative. So here we go. Then I'm doing this, and you see now this is going to be in the cell that I picked up here, but then I'm going to ask Amber if she can look at that slide we just had, and I think it was, I don't know if it was number 7 or 17, but it's the first one in the, yeah.
Okay, do you need N?
I do need N. That's
Okay.
the number of trials.
N is 10.
Hold on. So I'm typing 10 in the number of trials. Tell me something else.
P is 0.4.
Now that's the number of successes. So this is, let's see, 0.4. So I'm going to say 0.4. And I'll put the 0 in there automatically, I think. And then the number of successes was what?
3.
Okay. And then I think I'm just going to put 0 here. Let's see, use true or false. So this is false. I don't want the cumulative thing. And so this is going to be false. Okay, so I get that. So that is the probability of this first one. Now, Amber, and I realize I'm asking you to do more things, but that's kind of okay. Why don't you go to one of those other problems that I spoke about, where it says like, x being greater than 3 or something, and tell the students what problem you're picking. Okay.
I believe.
Yeah, go ahead.
You said number 24. N equals 10, P.
All right, n equals 10. Now I'm going to use that because I'm going to build a table here. Okay, so this is n. Okay, so this is going to be n is 10, and I guess I just will remember that. But then what I'm going to do is this is x. This is the number of successes. Now, if there is 10, there can be 0 successes, or there can be 1 success, 2 success, 3 success, 4 success, 5 success, 6 success, 7 success. I screwed that up, damn it. I got to turn on a light in here someday. Okay, so this is going to be 7, then it will be 8. I have to go down then. I should go over. Okay, so this is going to be 8. 9, and there can even be 10 successes, can't there? Okay, so this is the number of successes, okay? But then what I'm going to do is I'm going to use this is where I put the probability. So this is going to be P of X. So this is P parentheses X into parentheses, and there we go. And now I'm going to use this formula, okay? Now I'm going to click here again. And I know that this was DIS, or it was binomial DIST. Okay, so I'm finding it somewhere. That's not it. Okay, so we'll try that again. I wonder if when Linda, goes off to her meeting, if 7 can do Excel. I bet so. Anyway, we'll go down to binomial. There it is, binomial distribution. It's that one. Okay, and then I'm going to do this. Now, what I'm going to do is I'm going to put some things here, but I'm going to just pull them down, some of the things down. Now, the number of successes is going to be whatever is in this column. That's enabling me to pull it down. It is always going to be, how many trials did you say, Amber?
The trials, 10.
Okay, so again, it is 10 apparently. Okay, and the probability of success this time is?
0.65.
Okay, it is 0.65. That's good. And again, I'm going to do false. Okay, so you see, I'm going to say that is good with that, but then I'm going to pull this all down. And so you see, now I have calculated the binomial probability for all of those events. And let's see, did that end up being right? I'm not sure that that ended up being right, so I want to check that. Okay, I don't know what's going on. People are saying something, so maybe I have to answer some questions. Let me go see what's going on, and I guess I have to stop sharing my screen. And okay, yes, Sebastian, what is your question? I think I screwed that up as I was doing it. Go ahead, Sebastian.
No, I was wondering where I can find all the formulas or equation through the Blackboard, so I can.
Okay, I will show. Well, first of all, they're in the video, but I know what your question is. So I'm going to show you the formula. But once you see the formula, Sebastian, you're going to say, oh, I want to do Excel with the formula. So I'm going to answer his question, and I think,
Well,
and I do
I was
always.
talking about the whole formulas or equations that we've been using in the last, I guess, 2 weeks.
Well,
So
I've been sharing them with you, and somebody asked early. It may have been Amber, but I don't know if it was Amber. She asked, well, are we going to share the grace notes? So maybe, Sebastian, I want to make sure I'm answering your question. Were you saying, what formula am I using now, or just where is the formula that I am using now, or were you asking, am I going to let you see the formulas on the grace notes? Or say your question again. I'm sorry, I just want to be clear so I can answer your question.
Well, actually, I think it's the same question that Amber asked before. Just because I'm right now I'm listening to you guys and I'm doing like anatomy homework right now, so I think I missed a part. But yeah.
So you're doing anatomy and listening to us. Okay.
No,
I'm
doing with my hand. I'm just writing down.
No, I understand. Now I understand what you're saying now. Yeah. Okay. So I think I stopped sharing, and I think you can see. I think you'll be able to see soon a PowerPoint slide. So I'm going to click on something here for the PowerPoint slide. And I'm going up here and I'm clicking on, let's see, this one. Okay, can you see a PowerPoint slide, Sebastian?
No.
Okay, I'm going to share my screen with you. I have to find Blackboard. Okay, now I'm going to share my screen. Oh, I share the screen a different place than I do on Zoom. So I'm going to share my application screen. And so soon you will see a PowerPoint slide. And this will be the answer to your question will be here somewhere. Okay, so you should be able to see a PowerPoint slide now, Sebastian, yes?
Yes.
Okay, this first thing, and you maybe can't see me wave it, but it's the first thing in the right-hand panel of your screen, and that's binomial probability distribution function. So the probability of X is going to be n choose X. That's quite a calculation into itself. And then it's n choose X times P of X, where P is the probability of success and X is the number of successes that you have. And then it is 1 minus P raised to the exponent of n minus X. So you see, that's quite a formula, and that's why I'm encouraging you to use the the Excel functions. And I always do watch what time it is, and I've blown my allotted time, but we did get into the binomial distribution, and we talked a little bit about doing calculations. So we'll pick it up from here next time. I do have office hours tonight, and so on and so forth. So everybody, please take care. It's important for young people to be careful, and you all have videos to watch and things like that. So good night, and I will see you soon. And I'm going to go back, stop sharing screen. I hope I answered Sebastian's question. Anyway, I'm stopping sharing. Okay, good. I'm stopping sharing screen, and I'm going back, and I'm going to kill the recording. I guess I have to do it this way. Hold on. Whoops, stop.